So we are ready now to define logarithmic function or logarithmic functions. For b greater than 0 and b not equal to 1, y is equal to log to the base b of x is just equivalent to x equals b to the y. This one here is in log form, and this one here is exponential form. Take note of the difference. You can use from the exponential form to the logarithmic form in solving equations, or from logarithmic form to exponential form in solving equations. Whichever is easier to do, or whichever is the way in solving equations. Note that the log b to the base b of x is the exponent to which b must be raised to obtain x. Okay? So meaning you can use this form in finding the value of x in a particular equation. And also, note that a logarithm is an exponent. Here, y is equal to log bx, but y here is an exponent. So let's have now the log exponential conversions. Log exponential conversions. Just to feel the definition of the logarithmic functions. First, if we have log to the base 2 of 8 equals 3, based from the definition of logarithm here, based from the definition, this can be written as 8 equals 2 cubed, which is correct. 2 cubed is 8. Also, if we have log to the 25 of 5, which is equal to 1/2, is just equivalent to 5 equals 25 to the 1/2. Or take note that the square root of 25 is 5. Also, if we have log to the base 2 of 1/4 equals -2, is just equivalent to 1/4 equals 2 to the -2. Take note, 2 to the -2 is just 1/2 squared, which is 1/4. So example in solving solutions. Find y for y equals log to the base 4 of 8. So how do we do that? We will use this definition of logarithmic functions. So that's why do not forget this relationship, guys, of the logarithmic form to exponential form, or exponential form to logarithmic form. So y equals log to the base 4 of 8. From the definition, this is just 8 equals 4 to the y. And from our previous discussion on exponential functions, this can just be written as 2 cubed equals 2 to the 2y. So they have the same base. You can just equate 3 equals 2y, or 3/2 equals y. So that is now the value of y, or the expression of y. Another example, find x for log to the base 3 of x equals -2. Solution, this log to the base 3 of x equals -2. Again, from the definition, this is just equivalent to x equals 3 to the -2, which is x is equal to 1/3 squared, and that is 1/9. Okay, another example, find b for log to the base b of 1000 equals 3. So solution, take note guys, here we are asked to find the base. This log to the base b of 1000 equals 3 is just equivalent again from the definition. 1000 is just equal to b cubed, and that is 10 cubed equals b cubed. From the law a while ago of exponential functions, from the law of exponents, this is just 10 equals b. So that is the value of b. So let's list the properties of logarithmic functions now. If b, m, and n are positive real numbers, where b is not equal to 1, and p and x are real numbers, then these are the 8 properties that are very important in dealing with logarithmic functions and also in solving functions or solving equations involving logarithmic functions and exponential functions. So let's have an example. If log to the base e of 3 is equal to 1.10 and log to the base e of 7 is equal to 1.95, find a log to the base e of 7 over 3 and b log to the base e of cube root of 21. Okay. Solution for letter A. Take note that this is getting the logarithm of 7 over 3. So that's division. So we can use the property number 6. So we have log to the base e of 7 over 3 can just be expressed as log to the base e of 7 minus log to the base e of 3. And log to the base e of 7 is 1.95 and log to the base e of 3 is 1.10. So this is just 0.85. Now for letter B, log to the base e of cube root of 21. Take note that cube root of 21 can also be written as 21 in terms of exponents, which is 1/3. So log to the base e of 21 to the power of 1/3. So from here, we can apply property number 7. So that we can write this one as 1/3 log to the base e. And also, since we do not know what's the log to the base e of 21, we can express 21 as 3 times 7. Now, this log to the base e of 3 times 7 is a multiplication. So, we can apply property number 5. So, we have 1/3 log to the base e of 3 plus log to the base e of 7. Now, since we have this log to the base e of 3 and log to the base e of 7, then we can just substitute. So, this is 1.10 plus 1.95. Everything is 1.02. Another example. Find x so that log to the base b of x is equal to 2/3 times log to the base b of 27 plus 2 log to the base b of 2 minus log to the base b of 3. So from here, this expression here, log to the base b of x, this expression here is expressed in terms of log to the base b of 27 to the power of 2/3 from property number 7. So we can write this one as log to the base b 27 to the power of 2/3 plus this one here can also be written using the property number 7, log to the base b of 2 squared minus log to the base b of 3. But log to the base b of 27 to the power of 2/3 is just log to the base b of 9. So meaning cube root of 27, then squaring it. So that's 3 squared, that's 9. Plus, this one here is log to the base b of 4 minus log to the base b of 3. So here is just the multiplication to addition property. So that's property number 5. We can write that one as log to the base b of 9 times 4. But here is subtraction. We can apply the property number 6 again from division to subtraction. So we have 3. So therefore, this one here is simply log to the base b of 12. So take note guys that log to the base b of x is equal to log to the base b of 12. From this, from the last property, from the 8th property, if we have log to the base b of m equals log to the base b of n, that is just equivalent to m equals n. So therefore here, x equals 12. And your solution is 12. Now take note of these misconceptions guys. This is, when you say misconceptions, common errors committed by students. Take note that log to the base b of x cube is not equivalent to log to the base b of x cube. Okay, take note of that. Because here, it's the entire logarithm that you are cubing, and here, it's just the expression x. Next, log to the base b of m over log to the base b of n is not equal to log to the base b of n minus log to the base b of n. Take note here, you are getting first the logarithm of m, then logarithm of n. In our rule, it's the logarithm of m over n, applying to log m minus log n. So they are not the same. Also, the log to the base b of m plus n is not equal to log to the base b of m plus log to the base b of n. Okay? What's our rule? It should be multiplication here so that you can apply this form from here. Rule number 5. Last one, common conception, the log to the base b of m to the power of p is not equivalent to p log to the base b of m. Okay, here, you are getting the power to the p of the entire log base b to the m. Our rule is you are just getting the power to the power of p of m, not the entire logarithm. So you are getting the logarithm of m to the p. So they are not equal. I hope that's clear with you. Now we have two special cases of logarithms. These are the common and natural logarithms. first, the common logarithms. So first, the common logarithms are logarithms with base 10. So if we have, say, log to the base 10 of x, this can also be written as log to the x, meaning you don't have to emphasize the base 10 here, because if there is no emphasis of base here, that automatically the base is 10. So log to the base 10 of x is equivalent to log of x. Also, the natural logarithms are logarithms with base e, and this is denoted by this one, natural logarithm, or ln of x, and that is equivalent to logarithm to the base e of x. So instead of writing logarithm to the base e, you can just write ln of x. That means natural logarithms. So let's have the logarithmic and exponential relationships that will really help us in solving equations involving logarithms and exponents. So first, the log of x equals y is equivalent to x is equal to 10 to the y. Take note, when the base is not emphasized, that means that's a common logarithm and the base is 10. So here, 10 to the y. Also, the ln of x equals y is equivalent to the e equals e to the y. So when you say natural logarithm, that's automatically that the base is e. So let's solve now exponential and logarithmic functions.